Okay, so we are looking at orbitals. They're certain shapes that negative electron charge cloud can occupy. Okay, now in the first shell, if we look at the first shell, we have only got the s orbital, and we may call it the s subshell. Yeah, and there's just one of those. There's only one s orbital. When we get to the second one, so number 2, yeah, the main second quantum shell, there are 2 subshells there. You've got the s orbital, which can fit one in it, which has got one of them, and there is a p orbital as well, and there are 3 p orbitals. So we carry on this pattern. You might expect to see when you get to the third shell, you'd have an s orbital, and you'd have one of them. You'd have a p orbital, and there'd be 3 of them, and there'd be another orbital. Okay, and actually let's call that the d. And how many of you guess would there be there? Well, this goes from 1 to 3, so you'd expect there to be 5 different d orbitals, and there are. If you look at this diagram here, so we look at the diagram on the left now, right? So we have got the first shell. There's just one subshell there, the s. When you go up to the second shell, there are 2 subshells. There's the s and the p, and then you've got 3 p orbitals. When you go to the third one, which I've coloured in blue, you can see you've got the 3s, one of them, 3p, 3 of them, and 3d. You've got 5 orbitals there, all with equal energy. And you probably would have noticed, definitely would have noticed, that something's funny going on here, because you've got the fourth shell. Okay, you've got 4s and 4p, and they kind of intermesh with the with parts of the third shell. And it's strange that the 4s orbital is slightly lower in energy than the 3d orbital. So that means before 3d gets filled up, 4s gets filled up. So let's have a look at our periodic table and see what's going on there then. Okay, so I'll get rid of that, I think. Right, here's our periodic table here. And so far we have done up to this element, haven't we? We've done up to argon, yeah. We've done up to argon. Well, so hydrogen and helium, okay, so they just electrons in 1s. Then we get onto the second shell, so that's why you know, the 2s and the 2p. Right, lithium and beryllium, they've just got electrons in 2s, haven't they? When you get to this lot over here, then you start filling up the p shell. Okay, the p shell starts filling up that way, doesn't it? They don't pair up unless they've got to. By the time you get to the noble gas, neon, you've got 6 electrons there. You've got 6 electrons, so that's completely full up. Then we have to move to the next period. We've got period 3 now. Okay, so we're in the third shell, and here we've got the element sodium. And sodium's got 1 electron in 3s, then you've got magnesium 2 there. Then we have to start filling up 3p, which is this lot here. Yeah. All the way to argon when you'll have 6 in there, and that's full up. I shouldn't do it like that, should I? I should fill the electrons up the way they do fill up. So separate orbitals, then they pair up when they've got to. And that takes us to potassium. Now potassium, the electron does not go into 3D, does it? It goes into 4s, because that's lower in energy. Calcium, likewise, it doesn't go into 3D, it pairs up in 4s. So when potassium and calcium are filled, then we start filling up, all these elements here. And you can, might as well tell you now that these are called the D block elements, and that's because you start filling up the D shell. Yeah, these ones here, these are called the S block, because in that bit you're filling up the last shell to be filled is S, and that block there is the P block, because the last subshell to be filled is a P. Right, so let's just rub that out. and concentrate on these concentrate on what's going to happen in the transition metals with the D block here. So we've got scandium there, yeah. So scandium, 1 electron in 3D, red. Titanium, next element along, yeah. No, it's not going to go like that, is it? No, because it doesn't pair up unless it's got to. So it's going to go in that orbital. Then you get vanadium. So scandium, titanium, vanadium. Now chromium is a bit weird because chromium you might expect to be like that. But what actually, and don't worry about this now, you do it in year 13, what happens is that it borrows that electron there from 4s. And that goes in there. So chromium, the electronic structure of chromium is blah, 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 blah. It is 4s1 3d5. It's not 4s2 3d4. The usual explanation for that is because you've got extra stability filled with a half, when you've got a half filled shell. I don't know, it's a bit of a vague explanation, but anyway, you do get 4s1 3d5, not 4s2 3d4. Right, then when you go to manganese, which is after chromium here, then, you know, manganese is 3d, you know, that goes there. So manganese is 4s2 3d5. Then they start filling up. They used to have to start pairing the electrons up there. Right, that would be when you get to nickel, okay, is like that. And then with copper, you might expect that to happen with copper, but well, actually it borrows this electron back again, you know, like it did before. So copper is not 4s 1 3d9. Copper is 4s2. Sorry about that. Copper is not 4s2 3d9. It is 4s1 3d10. It's got a fully filled D shell. And then finally, zinc is the last element. So zinc is going to be 4s2 3d10. So there's zinc. After zinc is filled up, then you just start filling up the 4p. So that's why we're in the p block now. So gallium, yeah, you'd fill gallium would have like that, and then you'd carry on filling it all the way up to krypton. Krypton, krypton, it will be a completely filled 4p. Oh, just before we finish, right? What's the shape of the d orbitals? Well, the s orbitals we know are the s orbitals are spherical, so 1s is small, then 2s is bigger, 3s, and 4s is going to be bigger still. The p orbitals, yeah, you have 3 of them, and they are right angles to each other. You know, one like that, and then one like that. That's the p orbitals. The d orbitals, you can look them up online. I'm not going to try and draw them because they're too difficult to draw. But the d orbitals, you've got 5 of them, and they've got lobes in them like the p orbitals. Yeah, so a bit similar to that, but a little bit more complicated. But don't worry about it. It's the same sort of idea. They are they sort of get as far away from each other as possible. Okay, we'll leave that there.